be doing this problem today. Okay. In this case, a block has been given which is kept on an inclined plane which is tilted at an angle of 35 degrees, and the block is attached with a string. The string further rolls over a pulley, and the string is tied with a weight B. The arrangement is arranged in such a manner that the block just moves down due to the weight of B. Okay, and the weight of block is given to be 2000 newtons. I hope so it's visible. 2000 newtons. Let us consider this force B, and the string is tilted with an angle theta with respect to the inclined surface over which the block has been kept, and the angle theta is given such as something 20 degrees, and the coefficient of friction given is 0.2. Okay, now firstly we will resolve all the forces with respect to the inclined surface over which the block has been kept. So firstly we will resolve the weight force. So it will be something, this force here and here. If I extend this line and I extend this line, the angle forming here will be 35 degree. As we can see, these two angles are adjacent angles. Simple school geometry. Now this angle is a right angle, and this whole system is forming a triangle. Such we can see that 35 plus 90 plus x equals 180 will give us this angle. So it is 125 minus 180. 180 minus 125 will give us something for 180 minus 125. It's 55 degrees. This angle will be 55 degrees. So we can write here 2000 cos of 55, and here 2000 sine of 55. Okay, 35 plus 90 plus x equals 180 plus 55. Yeah, it's correct. Now we'll resolve the string force B with respect to the inclined surface. This will be one component, and this will be one force component. So it will be like d cos 20 and d sin 20, as this theta value is given as 20 degrees. So we can write this as so. I erase this part. It will create a bit of confusion, so I'll erase the geometry part of this, and we'll only analyze the force part of the problem. Okay, now we have to calculate the weight B in such a manner that the block moves forward, or it slowly the block moves in upward direction. Yeah, so as we can see this, we can apply conditions of equilibrium over here. Equilibrium. Before that, a frictional force will act opposite to the direction of motion, and due to this frictional force, a normal force will act over the block. Okay. Firstly, we'll take the sum of all vertical forces equals to 0. It is equal to 0 because the block is at rest. Therefore, the summation of all vertical forces should be 0 in that case. So we'll take the upwardmost force as positive. Okay. We take N plus B sine 20 minus 2000 sine of 55 equated as 0. Let me check that I have taken all the vertical forces. N plus B sine 20. Yeah, that's it. All vertical forces have been accounted over here. Now let me check the value of 2000 of sine 55. It is something 1638.304. So we can write it as N plus B sine 20 equals 1638.304. I'll mark this as an equation number 1. Okay, I mark this as an equation number 1. Now we calculate friction force F of F, that is N times coefficient of friction, that is normal force times coefficient of friction. Normal force we see here as 1638.304 minus B sine 20. How come this term comes here? I'll show you. This is our equation number 1. If I put this B sine 20 at that side, it will become negative. Therefore, we get N is equal to 1638.304 minus B sine 20. Okay. So this is my F of F. I'll mark this as my equation number B. Now I take sum of all horizontal forces and considering the rightmost facing force as positive. Okay. Now F of X. Firstly, we'll take this B cos 20 wala force. B cos 20. I take this positive because it is facing right towards right, and minus 2000 cos 55. Cos 55. Proper? Is it visible? Yeah. Minus 2000 cos 55. And the frictional force F minus, instead of writing F of F, I'll choose to write this whole term 1638.304 minus B sine of 20. This whole term multiplied by point. Wait a minute. The coefficient of friction is 0.2. I'm sorry, 0.2. I'll take this as 0.2. No more horizontal forces, I think so. Yeah, I'll equate it 0. After solving this equation, I'll get the value of B. I'll check the value of B in my calci. Minus 2000 cos 55 minus 1638.304 minus x sine of 20 2.2 was, I'll cross check the whole term. 1638.304 minus x sin 20.2. The value of B comes out to be 146.9685 newtons. This is the final answer. The value of B states that 1462.9685 newtons is required to push the block in upward direction. Means the minimum weight of block B should be 1462.9685 newtons, so that the block moves in upward direction. Okay, so this was a simple problem on friction.